So Mr. Franke is the owner of Test of Time Horology in New London, Wisconsin. It does a lot of restoration, so he gets to see a lot of the fun stuff that many of us don't see when we're working on the modern stuff. So I absolutely look forward to this presentation. We got a little bit of a teaser last night. He didn't let all the cats out of the bag, but I'm really looking forward to what he's got to present to us today. So without any further ado, Mr. Franke, the floor is now yours.
All right. Thank you. Thank you, Jason. I dodged a bullet with David not being here this morning. For those of you who don't know, David Lindo was my primary mentor in my journey into clock making, clock restoration. So we've been very good friends and colleagues for north of 12 years now, I think. So anyway, thank you for having me this morning. My presentation to you is going to be regarding lapidary in the name of horology. I thought it was sort of a fitting term. My journey into lapidary was one that was born out of necessity. I was faced with certain circumstances in my career where it led me down this road. And I know Rune gave a talk on Thursday evening, and there's something he said that really resonated with me. Horology is all-encompassing. And I thought to myself, that's exactly tying into my experience here with stone cutting. And it truly is. So you don't go to the bench one day thinking, okay, I'm going to be essentially cutting sapphire and making gems, but you never know where this trade might bring you and who you might need to meet. First of all, let's just have a little bit of a background. What is this substance called corundum? It's aluminum, or basically aluminum oxide, Al2O3. In nature, it's called sapphire, corundum, ruby. It's 9 on the Mohs scale, so it's extremely hard. The only thing harder is diamond, which is 10. And pure corundum is clear and colorless. It looks like glass, essentially. Rubies and sapphires, these terms get used a lot. I've learned that they are the same thing. They are species of corundum. The difference is the trace elements which give them their color. For example, rubies have chromium, or trace amounts of chromium, which gives them the red color, whereas blue, it's iron. Other trace elements give stones different color as well, but their family is the corundum family. Many uses in industry, we see abrasive powders, which is similar or essentially the same thing as aluminum oxide. That's crushed ruby, and very important in our industry, in the jewelry industry. My journey, Philip gave a great presentation on the historical aspect from the watchmaking perspective. Today, I'm going to be talking to you in a different way from a clockmaker's perspective, using almost exclusively synthetic ruby, which I'll touch on a little more later. But synthetic corundum, it's an artificial gemstone, and the horology industry uses this almost exclusively. And during a little bit of research, I discovered that there are 2 different ways to make synthetic ruby, and they have a little bit different properties. Now, I gave this presentation back in May, and during my research, I wasn't exactly sure between the 2 methods how to differentiate. And when I came here, word reached my ears that there was an expert gemologist in the room, so I couldn't just gamble on the notion that nobody else in the room would know either if I were wrong. It was a reality check. So speaking with Andrea, I don't know if she's here this morning, I had to confirm a few things. And there are 2 ways to make synthetic corundum. One is called flame fusion, the other is called pulling, or pulling the crystal. I don't want to get too involved with what those are, it's beyond the scope, but basically a lot of these 2 methods, these expanded greatly during the US involvement in World War II. Synthetic sapphire was needed for the war machine, including making things like marine chronometers and other delicate instruments that needed ruby bearings. Why do we use synthetic corundum, or what's the advantages? Well, for one thing, it's controllable. Whereas natural stones have lots of inclusions and things called an axis of crystallization. You get none of that with synthetic ruby. It's also very cheap. I have two types. We have a pulled crystal here, which actually, after talking with Andrea, describing it to her, it's probably a flame fusion boule. But at the time, I didn't know any better. And then down here, we see a typical flame fusion boule. They are very cheap. I think this is probably about 3 inches long or so, and you can get one on eBay for about $30 to $40. So it's readily available, and most of you guys, this would be 2 lifetimes of a supply of what you actually need. A little bit more synthetic corundum, just what you find. My little stone that I purchased here reminded me very much of the sorcerer's stones. Something else, flame fusion boules. I have an array of them in the left there. They're inexpensive, but watch out for what is called a color rind. And this was something I was not aware of. And in flame fusion, they irradiate the boule with certain methods to give it its color. I'm not an expert in that, but this is what you'll find oftentimes if you slice it, and it's this beautiful blue, but you cut it and you realize that it's just concentrated on the outside and it's shooting the color through the rest of the boule. And by the way, throughout this whole presentation, I want to disclaim that I am by no means an expert in this, okay? This has just been my experience for you guys this morning. So I've already had to amend this talk a few times since May because I've learned certain things. So corundum in clocks, why do we use it, or watches too for that matter? Here are some advantages of corundum in horology. Since it's very hard, it's also very durable. It can be polished to exceptionally high finishes and even up to 1/4 micron, which is equivalent to about 100,000 grit. The hardness allows small parts or parts that see frequent motion to withstand wear, or also reduce friction greatly. An example of that might be like an olive jewel or a cap jewel in a watch or clock. It increases longevity greatly, and it also adds a sort of a sense of sophistication and quality, especially in clockmaking. You don't see jeweled clocks as often as you see watches where they're commonplace. It looks impressive, and it shows a higher skill level. So backing up a little bit, how did I begin? Where did all of this start in my journey? Well, back in 2017, I was working on building a regulator on commission for a client, and they expressed to me that they wanted the escapement to be jeweled. I said, okay, and at the time I was working with David Lindo in his shop. I thought maybe we can get the sort of insert jewel pallets and put them in there. That would be the easy way, and I think there were even a few companies that sold them, and David said to me, well, you can do that, and that would work, but if you wanted to do it expeditiously, you should take stones and set them into the pallets. It's better and it's more sophisticated, and that was his way of saying you can't take the easy way out. You have to take the difficult way out. Neither of us had made jewels of any kind before, and the anchor, or the deadbeat anchor for the clock that you see in the photo, was made entirely by hand. I had no access to CNC of any kind in this time, so it was cut out with a jeweler's saw, and the rubies themselves, you can see in the bottom right, we were able to source natural ruby. We had no idea about synthetic sapphire or how to obtain it. So jeweled anchor continued. How did I go about doing this? Well, I figured if I can take the stone and grind it on an AccuFinish grinder, since it's diamond, I should at least be able to shape the thing. And in the process here, what I did is I ended up gluing the end of the stone to a piece of bar stock and got it into a cube or a cuboid. And eventually we ended up having to make laps out of cast iron. So we had to make the tool to make the tool to make the part sort of thing. And they work great. Unfortunately, I no longer have photos of the iron laps. but I used the laps, charged it with, I think it was diamond spray, like you would on an AccuFinish, and used that for polishing. It was brutal, it was painful, and I would never ever use natural ruby again. This is where I learned don't use it, and I think you probably can even see in up here the little bubbles and inclusions in the stone. They also have what's called an axis of crystallization, where it's how the crystal grows, and if you go against the axis of crystallization, you can fracture or break it. Never ever again. I have 40 hours into this piece alone, and it was painful, but in the end, I was able to produce a somewhat respectable anchor by hand, and with pretty good polishing on the gemstones. But I thought to myself, okay, I hope I never have to do this again, and there has to be a better way, right? So, of course, I was stupid enough in the future to put myself in a position where I needed to and enter the German students regulator, taking on a tough job. This was around 2023 when I took this in. So several years had passed after making my regulator. I had not touched stones. It went out of my mind completely. But in 2023, I was approached by a client who had it was like circa 1950s German engineering students clock that had some problems with the escapement. And he said that the stones had been damaged, or some of the jewels had been damaged during shipping. Long story short, it got sent back to Europe, and it had a botched palette stone job done to it. And I said, yeah, I had some experience in stone cutting, and I would take on the challenge. I said, yes, of course, sure, send it in. So one thing about this project that made it unique is it wasn't just a deadbeat or a Graham deadbeat escapement. It was a Strasser-style escapement, or a spring impulse escapement. So rather than relying on the impulse through the escape wheel directly to keep the pendulum going, it flexes a suspension spring, a compound suspension spring, through the escapement directly, eliminating some parts like the crutch, and the flexing of that spring itself is what keeps the pendulum in motion. A Riefler regulator works in a similar way, a little bit different, but same idea. So it's also on top of this an escapement I had never dealt with before. Okay, so we're dealing with a lot of unknowns. Plus now I have this lapidary thing thrown into the mix. So upon my assessment, yes, it was bad, and we can see from the photos the locking jewels were very poorly replaced. You can see from the photo that it looks almost like a toenail rather than a palette jewel, and they were, you can see it's like, what's that rock in Utah that's balancing on the, it was like that, and that was after removing the super glue that they had to keep it in place. So, you know, I'm looking at this, there's no saving these stones, and it was a mess, but I needed to learn about stone cutting first. And how do you do that? Where do you start? Working with sapphire, it's going down a deep hole. Where do you begin? So I asked myself, like, naturally I turned to the horological texts. Daniel's book being one of them. I read verbatim the jewel cutting section. I read Saulnier's. I've read some other obscure manuscripts. They all sort of said the same thing, and they were all, other than Daniel's text, which I think he pretty much took from Saulnier's, it was 100 years old or more. And they were written by people it came across as maybe have made a few things, but not a lot. And not that the old text is bad, it's just that now we have a lot more things available to us in our time. And like ivory, for example, where do you get ivory to polish something? Oh, you can, I guess, but I didn't have any. So I was starting to feel a little bit overwhelmed and maybe that I had made a mistake. And until I broke it down, I had this thought, okay, what am I trying to do in itself? What's my goal here? Well, I thought about it. A palette jewel is really nothing more than a gemstone, a faceted gemstone. And when I thought about it in that sense, it was like a eureka moment. And I had this idea, well, if I'm trying to make a gem, I'm not going to seek the advice of a horologist. I'm going to seek the advice of a gem cutter, because this is what they do, and this is what I needed to learn how to do. So enter Brian Drummond, and I don't know, BD Mastermind. He's out of Las Vegas, Nevada. He does some wild, wild gem cutting work, and I had known him through Instagram previously, but had not spoken to him directly or interacted with him. So I reached out with him, and I said, hey man, I love your work. Like, it's crazy. I just want to like learn to make a cube, right? So I said, I'm working with corundum, synthetic sapphire. He's like, oh yeah. He goes on this discourse about, I'm like, wait, slow down. Yeah. So let me get my pen and pencil. Another book that came in extremely handy was John Sinkankis's book on gem cutting. You see it here. Wonderful, wonderful book. Took lots of notes from that. But what was more beautiful about this is there was cross-pollination starting to happen between two very different worlds, my clock world and his gem cutting world. And Brian's advice probably cut my learning curve by 6 months, if not more. I would have been lost, and things that are not intuitive about working with sapphire. So fantastic contact and friend, ultimately, that I made. And he'd probably be upset at me if he saw I went on his Instagram and screenshot a bunch of images of him. So fantastic stuff here. Let's see what's going on. So working with sapphire, what do you need? What do you need to begin? Well, it's a unique material, and most of us have worked with metals. Stones are nothing like working with any metal. They require their own handling, they require their own methods and equipment. And from my experience, I ended up categorizing how to work with sapphire into 4 different steps. Essentially, there's sawing, grinding and shaping, pre-polishing, and then polishing. I sub-compartmentalized it into those 4 stages, and each stage requires special tools and techniques. So let's start. Tools and techniques. Sawing. When you go online and you buy this boule, it's not very useful. How the heck do I go from a boule to something workable, and it's so darn hard, nothing cuts it, almost nothing. Which led me to having to get some lapidary equipment, first of all, to be able to make a chunk, to work with. So the sawing, when you're sawing something, generally people do it to cubes. You need to use diamond saw blades. There's a plethora of them out there with the jewelry industry now. The jewelry world, there's no shortage of tools, but what do you get? Here are some examples of the tools that are needed. This is a lapidary trim saw. This is a lapidary band saw. And these are some sintered diamond blades. And diamond blades can get very, very thin, some as thin as under 10,000ths of an inch. Water or coolant must be administered at all times. This can be water, mineral oil, WD-40. I'm a fan of WD-40 because it's machine friendly. And you want to do these steps on medium to high RPMs. You got to saw this stone. You got to saw this boule into workable chunks. And having a little bit of fun with my lapidary trim saw that I acquired, I was able to just take a rock from a granite rock and make a little paperweight just for fun. Sawing continued. It's a slow process, or it can be a very slow process. And I had some some where I don't even remember where I saw it anymore, but there were examples online of somebody who had made a gang saw on their lathe. And I thought, well, geez, this is a great idea. I can, rather than just cutting one piece at a time, you can put a bunch of these sintered diamond laps or diamond saw blades together, and you can cut 4, 5, 6, 7, 8 pieces at a time. And so I built a spindle for my hard hinge lathe, and some spacers, and the thickness of the spacers determines the thickness of your chunk that you're cutting. And the end result is, here you take a stone, you glue it to a block of wood or a block of aluminum, whatever, and it kind of looks like an ice cube tray when you're done. And sawing some continue, it's a slow process. Naturally, the gadget mechanician, that's clockmaker in me, developed a automatic feed system for my gang saw using my cross slide. And I came up with a feed rate of about 1/1000th of an inch every 6 seconds as a feed rate with coolant on it. But it's worth the wait. And we have a little video going on here of my gang saw in action and my very sophisticated auto feed system of a clock wheel and pinion with my stepper motor on jog for my CNC indexer. So, but the wafers that I'm able to cut were about 10 by 10 by 0.3 millimeters without fracture or damage. So I was satisfied with that, and we even gave FDR some sunglasses there, some little pink sunglasses. So I was getting the results for sawing great. Where do you go from there? Because there's a long way to go. I needed to shape it, I needed to polish this, and I needed to maintain certain geometries for this clock. So continuing on, what's next? Well, grinding and shaping. Okay, you have a cube. How do you get this very, very hard stone to shape? Well, during the grinding and shaping process, here's some tools and techniques that you use. Plated diamond discs work extremely well, and they're cheap and they're very available. Some brands, DMT and THK. An AWCI is a wonderful tool for this. If you don't want to build an elaborate setup, you can get things roughed out and roughed to shape very quickly. The grits that you're generally working with during grinding and shaping is anywhere from 350 to 600 to 1200 grits. I found that beyond 1200, like when you get to 3000 or something, there's really no noticeable difference. And you're not getting the job done quick enough. In grinding, you want to get it done very quickly. I think it was Jacob's black polishing. It's similar, where you want to spend as little of time as possible in each step, or you risk fracture, scratching, whatever. Traditionally, before they had sintered diamonds, they had laps that were charged with very coarse diamond paste. Jacob and Michael talked about that a little yesterday. You must have coolant again. You do not want this dust floating around your shop, for one thing. The other thing is it gets very hot when you're grinding. You can grind on medium to high RPMs, maybe, I don't know, anywhere from 1,500 to 3,000 RPM would be considered medium to high, but you don't need it necessarily, because AWCI are more around like 350 RPM, and it works very well. It just takes longer, but it stays cooler longer as well. Again, WD-40, I like it because it's machine friendly as opposed to water. We got some various diamond discs here. Stones, they can also be done by hand, but I wouldn't recommend it. You'll be there all day. Here's an adapted setup similar to an AWCI, but on my cross slide, shaping it by hand. I'm holding the stone in a little pincher that I made, or a clamp, and then just grinding it on my lathe that way. Once you have the stone roughed out, basically to shape, then you do a step called pre-polishing. And it's exactly what it sounds like. You're getting the surface ready before final polishing. Switching to charged laps as opposed to sintered coarse things. After grinding and roughing the shape, you can get the scratches out, again, as quickly as possible. So to do pre-polishing, you want to use laps: cast iron, copper, bronze, aluminum, tin, zinc, ceramic, ivory, even lignum vitae, all make great laps. Cast iron, copper, and bronze work great for pre-polishing. Pre-polishing, as far as coarseness goes, this would generally be between about 2,000 grit to 6,000 grit. So that's like 10 micron and 6 micron respectively. Pastes, most of my work that I've done is well, I'm going to say all of my work is with the diamond paste you can find online. I see no need to mix diamond anymore. Again, this is a job that was born out of necessity. I have to try to learn it quickly and cheaply. Yeah, and it's the same thing as what Jacob was saying with black polishing. You take the paste, you rub it into the lap, you pre-charge it or charge it, and once you do this with the lap, it is committed to that grit. There's no, okay, I'm going to clean it off, and now my 1,000 grit's going to become 3,000 grit. It will not work. The coarser material will overpower the fine one always. So you need lots of laps. And here are some copper laps that I made, and one adapted to my AWCI. I didn't know any better at the time. Copper worked great, but I've come to find out there are better materials. So slow to medium RPMs, and again, you use coolant or maybe a little rag or a sponge dipped in either water or WD-40, held against the stone, or the lap, excuse me, so it's clearing away the swarf, and you're keeping the stone cool at the same time. Another example of a device you could use for lapping or pre-polishing or polishing. This is happens to be a Lapwrite tool that I obtained from the Bullevo factory, or it's originally where it came from. I have not used it yet. It's still in my garage, but I definitely intend to use it eventually. So tools and techniques, final polishing. So you get this pre-polish. Pre-polishing is also your final shaping. I forgot to mention that once the stone is roughed out, you can pre-polish, and believe it or not, even with 3 micron paste, you remove material pretty quickly. You get down to your final shape pretty fast, and you have to be careful or you're going to go too far and you're going to lose dimension. So next, final polishing. It's very, very similar to pre-polishing. It's essentially exactly the same except your grits that you're using. And again, all the same laps, materials work for polishing as they would for pre-polishing, including ceramic. I'm going to get back to that later because that's a little story in and of itself. This is typically 1 micron and higher, even up to 1/4 micron to get just that very beautiful liquidy finish onto the top of a stone. The laps are charged the exact same way. Paste or spray, paste rubbed into the lap. Use coolant and practice great cleanliness. I probably do not practice as good of cleanliness as I should, but I am very careful. You never want laps to meet one another in a drawer. You want to keep them separate. Again, you're dealing with microabrasives here, so always have a conscientiousness of what that abrasive, where it is, where it's going, and is it on me? Is it on your person? You know, your hands, your clothing. I've said it before, diamond and sapphires are like the cancer of machines, okay? Once they get in there, you embed, most machine beds are iron. Well, guess what else makes a great lap? Iron, okay? So be very conscientious of this. And the end result of my final polishing on my stone was this right here. Now, I did lap into the frame a little bit. Since then, I figured out how to do it much better. Essentially, which by the way, this was held in by shellac. I shellacked it in and then ground it, pre-polished it. But what I learned later to do on a different regulator project was to take this stone and after pre-polishing, reheat it, move the stone out, do the final polishing or final shaping, and then move it back in flush with the frame. And on the rear side of it, where it'd still be a bit proud, you pre-polish it in as close to the frame as possible without touching the steel. So in a repair job, you want to avoid changing original geometries at all costs. When you're making something that's a little bit different, but even when, because if I were to turn this around in the final result, you would see that this stone is ever so slightly proud from the back, and I mean maybe by a thou or two. It's not flush, but it doesn't need to be. So that was just something I had learned on the way. Practice exercise, so backing up just a little bit, before I began with the regulator, after I had talked to Brian, I gave myself the task of the challenge of let's just make a cube, okay? Let's get one surface polished on a cube. And this was the cuboid that I had made. And when I got that finished, that was a milestone, okay? That was an absolute milestone and a triumph to just be able to get one surface polished, dead flat, perfectly on a large piece of sapphire. So that was my practice exercise, and it's similar to polishing the side of a bolt. I think that's what a lot of guys do in bracelet finishing, right? It's similar. So going back, making the jewels, I covered some of this already, but we can summarize the steps now from what I had learned through my research. We first start by sawing the boule, right, into a chunk, a workable cube, sawing the blocks, the little pallet blanks on my bands or gang saw. I shellacked the blank to the frame and ground it to approximate shape, pre-polished, and then final polished. I happen to use lignum vitae for final polishing, although I think after more experience since the time this was made, tin works much better. This led me down another rabbit hole. I wanted to create a setup for my lathe that could hold the stone and do it mechanized or more automatically rather than just sitting at the AWCI or doing it by hand. So I went down this whole little sub-project of building a setup on my cross slide, which is built from an old shoreline bed, and a shoreline cross slide with a few things going on here. The pallet stone's out here, and this device that pivots here that's under pressure. And this would drive the stone into the lap automatically, keeping pressure on it. And I had a little test indicator here to be able to tell if it was touching the lap or not. And with stone cutting or with stone polishing, this is very, very important. Nothing can be rigid when you're doing this. With metal working or a cross slide, everything's rigid, as it should be. But during early experiments, I was just taking a stone, putting it on my cross slider and my tool holder, driving into the lap to polish. I would immediately score the lap. I would break the stone. And I went back to Brian, and I saw how a gem cutter does it, and they're doing it all by hand. They're doing it in a way that allows the stone to sort of ride on the lap and have give. It has to float. It can't be rigid. So this gave me the idea to make this device here, and so it's not rigid. It's floating on this lap for the final polishing, and it's being pivoted right there under tension of a spring. Just totally hundreds of hours of obsessing about a way to hold it onto my cross slide. And being the inner face of the locking jewel, it needs to be radiused. So this piece here, oops, what happened here? Sorry about that. This disc that it was glued to was actually the diameter of the anchor itself. So, final results. These were my 2 pallet stones, and you can see how they turned out in the anchor in situ. I was pretty pleased with the finishing, how it came out. So, would it help if I said I stopped counting at around 60? I also did build the setup for the lathe, so figuring that in today, it was a long time. It was an academic experience. So the most important question of all, did it work? That's David's favorite thing to ask. Yes, in short. And you can see here the Strasser escapement, the spring impulse action. This is my teeny tiny locking jewel sticking probably no more than 5/1000ths of an inch out to catch the tip of the tooth and working against the escape wheel. I was able to get the clock within plus or minus half a second a month. So it was, I guess, a success. But the original toenail jewels, as I came to call them, did work. They did work, but the owner said it wasn't acceptable, and I said, yeah, I agree. We have to do something about that. So building a mechanized lapping attachment, touched on that a little bit, but ultimately for stone working, I did add a reciprocator to it to be able to do completely hands-free lapping. You can see the little setup there. Just absolutely ridiculous. But it's how I finished them, so I could actually step away and let the stone finish itself on my hard hinge. So some other things that I've dabbled in a little bit. Philip has done far more than I have on hole jewels. I have done some work, though, in making hole jewels specifically for clocks. And you can see here some industrial or some process. It's just like anything else. When you glue a stone, you catch the center of the stone. This is a diamond shard that I shellacked to a piece of stuff, and I used it to spot the stone. It works surprisingly well. The other thing I've used to spot stones is a little diamond scriber. You can find them on like MSC or McMaster Carr. It looks like a pen, and if you use that on a T-rest, it works unbelievably well to get the center of a stone. I didn't think it would work, but it did. On the right is a little shop-made diamond that I use for truing wheels and things. It does the same thing. Kind of an interesting, if you go to the NAWCC Museum in Columbia, they have a nice little display of the process of how hole jewels were made. This step is exactly what I just was telling you. You saw it, and you finish it rough, and then you pierce the stone and final polish, or what Philip elaborated much more. Hole jewels, a work in progress. I have never finished a jewel to date, although I've gotten close. These are giant ones. They're about 1/4 inch in diameter. Here are some various tools. You have diamond sintered tools for making the oil sink, grinding, and then pre-polishing. Here's some various form laps. Again, the same materials for making like pallet stones. You have steel, bronze, copper, lignum, and then something we call a piercing drill, which is a piece of tempered steel turned to diameter with diamond paste that you use to actually grind the hole into the jewel stone itself. And nobody's perfect. This was a jewel which came out of the student's regulator. the same one for which I made the pallets, and I think the students made the hole jewels as well. And you can see the pitting. This would have been pitting from grinding that they never got out during their pre-polishing and polishing. So nobody's perfect. This stuff isn't perfect, none of it. There are no clock gods. So getting smaller, I wanted to challenge myself once to see how small of a hole I could drill into a stone, and I was able to drill about 1/10 of a millimeter hole into a little end stone from a watch, and using 10 micron paste. I don't have a great camera setup, so sorry about that, but there's the little piercing drill there, again shown on a dime. It could almost be used as a toothpick for FDR. Interestingly, I used blue steel to make the piercing drill. All the sources said that you need to have it tempered more or back to gray. It works wonderfully. I was able to pierce the stone in about an hour. And when you do this, the hole comes out a little bit bigger. One thing I did not think about is that you have to take into consideration the size of the grit itself, and 10 micron added about 1/1000 of an inch onto the diameter of the hole, because the particles are floating around in there. And I finished piercing the stone the day before I left to come here, so I actually do have it with me later. If you find me and you want to see it, I can show it to you. But it came out to be about the size of what I would assume would be a staff pivot for a wristwatch. So, and I do have, this was a little setup here. Again, like Philip showed you yesterday, I use a pivot polisher adapted with a bronze lap to be able to chamfer edges, and it works fantastic. It almost grinds and polishes at the same time. And again, like other stonework, the pivot polisher is great because there's give to it. It's not rigid, it rocks. So you can actually set it against the stone as it's rotating, and it's moving with the shape of the stone with pressure, but ultimately comes into shape, to dimension. And that's the little jewel there. It's 1.2 millimeters in diameter, so it's teeny. So what are some other sapphire projects? One of them was a sapphire burnisher I made, which was an exercise in itself. I loved doing this because it just gave me more experience. I don't use it very often, but when I do, it's great. Some giant roller jewels. I'm building 2 escapement models, and these are actually Bricotte pallets for clocks that I adapted or polished. This was taken very early on in my journey. I would never recommend doing it this way again, but I didn't know any better at the time. I had a rigid setup, and it's amazing I didn't break the stone. But it's to show you how much we learn along the way. Passing jewel blanks. An acquaintance of mine needed some passing jewels for a desk chronometer. I said, okay, well, I can cut them for you, but I'm not making it. I'm not a watchmaker, so I made him like a 10 millimeter by 10 millimeter polished face. I think, what was it, 0.25 millimeter thick wafer of sapphire that I polished and then sawed on my gang saw into lots of little blanks that he could then take, shellac into the staff, and grind to final dimension. Here are the little guys in here. That was an interesting project. Platform end stone. I have done a little work with platforms, but this was an end stone that I took, lapped down, primarily used Jacob's tripod to do that. Did it work? Yes. A little bit out of my jurisdiction here, but that was a more recent project. So, coming back to something here, ceramic laps, I alluded to them, and one night I was polishing a carbide cutter and drinking a Miller Lite, and I thought to myself, you know, I wonder how ceramic works on sapphire with spray. And I took a piece of corundum, put it on a ceramic lap with 1/2 micron diamond spray, and it was like a breakthrough. I was able to polish a surface that was rough sawn to mirror in probably about 2 minutes. So it's something that I want to explore more, and since then I've been using ceramic and diamond spray on flat, like if I want to polish flat surfaces of stone, and I was able to polish probably a surface area 20 millimeters by 10 millimeters, a cross section of a boule to absolute perfection using a dry ceramic lap. So this is something I want to explore more. The problem is ceramic laps that I know of only come in flat form. I wish I were able to adapt them to round or something to be able to polish oil sinks or non-flat surfaces. So there's more to be explored here. If you have done any jewel making at all, I would encourage you to try it. Just an AccuFinish ceramic lap and 1/2 micron AccuFinish diamond spray. So very interesting discovery. Something too that needs to be touched, what do you do after you work with sapphire? It's like cancer. Again, both sapphire dust and diamond dust are the cancers of machines. So when I'm done working with sapphire, sawing blanks on my hard hinge, typically I begin first by, I cover everything up to begin with. The bed, everything gets covered. I try to reduce as much material coming in contact with my machine as possible. When I'm done, the entire cross slide gets torn apart and cleaned. I don't want sapphire or slurry in my cross slide. And I typically clean it first with alcohol, rubbing alcohol. Diamond seems to have an affinity to alcohol, and Windex. And then the bed of the lathe also gets very meticulously cleaned and re-oiled. Choosing a machine to do this on, if you have the luxury of multiple machines, use a machine that's for dirty work. Avoid using a freshly rebuilt lathe at all costs. You can buy watchmakers lathes or little cheap 8mm lathes for next to nothing. Or even like if you have an Atlas lathe or something grody and you just want to saw some stone, or you get an entirely different machine like a Lapidary trim saw or something for your rough cutting. But most people don't have lots of machines, so you're forced to have to use your primary tooling. Be very cautious. It is playing with fire, okay? So cleanliness, very fundamental thing. That's been my journey. So one thing I would like to mention is if this interests you or making jewels interests you at all, check out the Elgin jewel making video on YouTube. It was illuminating to see that footage of what Elgin did. So thank you very much for your time. I appreciate it.
You know, Stephen, between you and I, the thing that impressed me the most about your presentation is you used millimeter in it far more than I expected. That would have been 0.
I decided to not fight it anymore. I'll just speak the language most people speak.
At least in this room, most
At least
of us.
in this
most
room.
of us.
So.
That was awesome, and I can also tell that David had nothing to do with it because that wouldn't have not happened. So, are there any questions for Mr. Franke this morning?
What's the primary use of the AccuFinish machine?
The primary use for the AccuFinish is for making tooling for the lathe, sharpening, maintaining edges, maintaining sharpness. Great tool. They're hard to find. It always seems the best tools are the hardest to find, and they quit making them. But if you don't have an AccuFinish, it's just as easy to build a fixture for AccuFinish or THK discs on your lathe and use the speed of your lathe to to grind and finish, or make a little angled block or something on your cross slide to be able to get the angles you need.
Even the GRS hones are getting harder to find now since everything's gone to
Yeah.
different style of engraving tools and things like that. Everything's gotten smaller, so even the bigger stuff's hard to find. What other questions can we entertain this morning? We weren't awake when you got here. You should definitely be awake now, because that's some amazing stuff.
Well, what was the source of those, you mentioned, I guess, the discs for the AccuFinish, or another THK or something like that?
Yeah. THK, I don't know, other people, does DMT make them? AccuFinish, what is it?
GRS.
GRS.
GRS
yes.
in Kansas sells them, and they also make a lot of the tools that are used now for the pneumatic engraving tools. And most of their product has now gone for the pneumatic engraving tools, whereas their older stuff that I kind of cut my teeth on, sharpening engravers and watchmaking, we use different fixtures and stuff, which it was a different method of holding from the AccuFinish. Very similar process. The discs are still available from them,
Yeah.
as I understand it.
The thing I liked about the THK stuff, where is it here? They're much cheaper. Like here, they're thin, so you have to put them on like a ceramic or a glass back or some kind of reinforcement. You can't use them. If you look on the lathe here, this is my glass disc that I use, and the THK disc itself is probably, I don't know, maybe to a millimeter thick. So, but they're like Kingsley North. I think you had mentioned cutting them into strips, and it's a fantastic idea. Yeah. So they're versatile, and they're like 20 or 30 bucks a piece. So you burn them out, throw it away, get a new one. Whereas the AccuFinish, the true AccuFinish wheels, are all machined true to the spindle and everything. So they're like $200 a piece. But Glencoe is another company that makes AccuFinish compatible lapping or grinding tools.
I was wondering if you had any good reference books, like you referred to
Yeah.
about like a piercing drill and.
So that's the road I went down, and the works I used, are you talking specifically for horology, like making a jewel, a whole jewel?
Maybe not for horology, but just good lapidary book.
Yeah, the gem cutting by John Sankis.
Yeah, I got
Is
that. Was there any other reference books?
That's the only one I explored.
Oh, okay.
Is my friend Brian Drummond recommended that one to me. The library has it here. That's how I first saw it. As far as actual stone cutting or gemology or gem making goes, in there they cover a wide variety of like how to facet, angles, what type of lapping material and speeds you use with certain types of stones. So it's pretty inclusive. A good source for clocks and watches, Saulnier's is a good one. There was a French manuscript as well from the late 1800s that I think Philip had translated recently that talks specifically period techniques on how they finished sapphires and things. The Daniels book, I'm going to say it's okay, but most of what he wrote is covered in Saulnier's. It's sort of redundancy.
Saulnier's, okay.
Saulnier's, yeah.
Thank you, sir.
You're welcome.
Can you show that slide that had that John guy's name?
Yeah, I'm trying to find that here.
So the gem cutting book is John Sinkankas, Sinkankas.
Yes.
Is that lapidary gem cutting book you're talking about? Justin Prim is another faceting, fantastic book
Okay.
to look at. His isn't specifically saying this is exactly how you do it, but it's more the angles, the symmetry, because when you're working with specific materials, it reflects light differently, if that matters to the job you're doing. But I don't want to go down that rabbit hole, but I
Yes,
thought
we
I'd
have
just
an expert
throw that up real quick.
gemologist here, so I had to fact check a few things. But the gem cutting, the John Sinkankis book is featured there. Yeah. Dennis?
We've been sharing stuff back and forth, and I see what you're doing, and I have to like strongly resist the urge to stay up all night and try to reproduce the things that you're doing. And you say the same thing to me. I'm like, please don't tell me anything else. I don't have time for this. And
It's
yeah,
a very bad combination.
it's just so much fun to see the stuff that you've been making, and now with this jewel cutting, I've cut jewels myself, and using the Daniel's book and everything, and I'm like, these guys, what did he make, like 3 jewels or something?
Yeah.
And
Yeah.
and it's some of the breakthroughs you've had, like I always tried using copper or soft iron and just suffered, and I'm like, you say, oh, I pierced through in an hour. That wasn't my experience. Mine was more like 12 hours. So it's
What
so
I
impressive.
should add to that, to the piercing, I've never done it with a live tool either, and I think that would really cut back. I'm holding the piercing drill in my rack and pinion tailstock. Well, and I'm thinking if I could do it in an hour, if I had a live tool, it probably would be, I don't know, Philip, you've done more than I have.
With the tailstock spindle spinning. We're
Yeah.
talking 15 minutes, maybe.
Unbelievable. So, yeah, and I found that just typical pivot steel works, and it's the only thing that would maintain any kind of integrity when I was doing it that small. And again, everybody says this stuff, but is it really true? Does it really not work? So you have to just go and try it. Like, nowhere did I ever read ceramics work, and I was blown away with how well. It's limited, again, like I said, because that's for flat surfaces, but perhaps it can be adapted for a quick way to do curvature or something. Yeah. This whole thing became like a pet passion project, so it's sort of like a hobby. Yeah.
How did you?
Oh, he's got it, Matt. Come on. Wait your turn.
Wait your turn, Matt. Have you ever had an interest or a curiosity in making your own bools?
My own bools?
Yeah.
Of course.
Like, have you thought about making your own vernal fusion furnace?
Yes.
I'm wondering how deep you would ever consider going.
Yes, but
It is a serious question.
I know, and that's a serious answer. Yes, I have. I've looked into making my own brass. I've looked into making my own raw materials. Yes, but at some point, you have to tell yourself no. You have to go in. Yeah, right. You have to go into life with an agenda sometimes, and learning when to stop. This applies to work too. Knowing when to be done is a skill I think that's rarely taught. When is it enough? When is this piece good enough? It's got to get done. It's got to get out the door. The same thing applies to these adventures I want to have. I'm relatively young, but someone told me once, it's like, you don't want to take your time to get up to the wall. You want to get up to the wall as quickly as possible and spend as much time there as possible. And what he was saying, like, we have this material available to us unlike ever before. Rather than spending the time on how to create it, let's spend as much time as possible on how to work with it to perfect your goal. Because we only have so much time.
That's a good answer. I'm just wondering the concept of handmade, like how deep do you go and still have the credibility? Like you mean you're not mining your own aluminum oxide out of the earth to make your bowls, to make your jewels? How handmade could it be? I understand the the argument there. Second question, can you elaborate on the cooling and the heat input of the cutting process? You mentioned that heat is a constraint. Can you talk about the thermal?
And the most heat you're going to experience is when you're grinding the stone. And I ground at very high RPMs, and the coolant, which typically is in most lapidary work or gem cutting work, they have a continuous flow going over the lap. I didn't have anything like that. I had a lathe. And so another method I saw in the clockmaking books or watchmaking books is having like a sponge soaked with a coolant on a little clip held against the lap itself. And it does a couple of things. Because actually in lapping, the heat is almost none. But what it's doing is it's removing the swarf from it. So when you're grinding, yes, it's preventing the sintered lap from loading up, and it's also keeping it cool. My experience is limited only to sapphire or synthetic sapphire, but from what I've read, in some gems, the heat can crack, it can cause chipping, it can cause streaking, and lots of things. So it's WD-40. Most guys use WD-40. I found that using it just sponge held against the revolving lap is plenty to keep it cool. And with ceramic, I found that dry works best. Dry with just the stone. When I showed you guys the cap jewel or the end stone that I modified, right here. Well, what I did is I glued the end stone into the metal frame, and I'm like, okay, well, this will be quick. I'm just going to put it on my ceramic lap. It actually chipped the stone, and I think what's going on is the swarf from the steel is coming around and interfering with it, whereas I had no problems with just a sapphire stone by itself against it. So for that one, I actually ended up finishing on a tripod on a tin lap like you would in black polishing, and that seemed to work a lot better when you have different species of material against it with coolant, or cleaning rather.
How did you apply the micron and submicron diamond spray to the ceramic?
I sprayed it on. I took the lap off of my machine. I sprayed it on, and I let the alcohol evaporate off of it, and it's good to go.
So you just applied it, let it dry?
Yep.
Okay.
Yep, and then...
And you segregated stones by grit?
Yes. Okay. Yeah, you have to... It's the same thing. They say that you can clean off a ceramic lap. I don't believe it. No. So, and when I'm done with the ceramic lap, with the cleanup, I always rub it down with alcohol on a piece of paper, like watch paper or tissue paper, let it dry, and then I put it away in the drawer. And then when I get it out, I wipe it down and then spray it or charge it. And you probably don't need to charge it every time. It's a habit I got into doing. Since I'm wiping it off with alcohol, I know some of the diamond is coming off with it.
But once you apply a certain diamond grit to it,
it's done. Treat it like it's done, in my opinion. Yeah. You use the other side. People do that.
Any other questions? Outstanding. We'll take a little break before our next presentation.
Thank you.
Give him another round of appreciation here.